Thank you. Good afternoon. I always like to get A's in school, so that's the title of my conversation, right? How do we get an A, the role of A? So I've long believed that every industry is going to be disrupted by social, mobile, analytics, and cloud, the SMAC stack. Government is really no different. And I think we can all probably agree easily today that social, mobile, and cloud have become the de facto standards, whether it's running a marketing campaign, whether you're trying to find a family member after a natural disaster, or whether you're moving work to Amazon Web Services cloud. The baby in that SMAC stack has been analytics. And this is the year that analytics is taking a much more maturing role, whether they're a teenager, full adult, I don't know yet, but you start to see it playing out in a lot of different cases. So whether it is an Internet of Things solution that has a back-end analytics, whether it's analytics used to improve the operational performance of companies, or it's analytics to define sub-segments, personalized marketing, new niches for companies' products and services. Analytics is the superior growth engine as we go into 2016. So I want to talk about a little bit how we're using analytics at Intel to help grow our business, right, and to drive operational performance improvement. And the first example I have is what we call SMART. So we have, the situation at Intel is our product portfolio is expanding, and with that expansion, so instead of selling just CPUs, we now have Internet of Things devices, we now have software, we now have gateways, home gateways, and different products and solutions that go to different customers. And so when that happens in a business, the sales organization comes in and says, hey, we got more customers, more products to sell. I would like more money to sell those things to more customers. And then the company, primarily led by finance says, yeah, that's an interesting story, but no, we can't afford it. And that's exactly what happened at Intel. And so we went into the channel reseller organization. So they're an outbound call center. So people on the phone calling customers, trying to find leads, and then ultimately companies who are going to design product on Intel architecture. And we said, well, we think we can help you with an analytics-based solution. We're going to have a predictive model that will tell you, instead of calling the customers that you currently call. So if it was a big account, they had a named salesperson on a named account. Smaller accounts, they'd say, hey, you call this territory, this group of accounts located in this particular region. We said, well, we don't really think that's the best way to do it. We think we can tell you through analysis of our data who would be the better people to call. And so we said, first of all, tell us, as learned salespeople, tell us what has to be true when you win a design win. And so they were able to tell us certain things like, well, you have to have some certified engineers, and you have to have a certain amount of budget in the R&D area for product design. They would have to come to visit an Intel website. Aha, I have logs on Intel websites, right? I actually have learning curriculum that people come in and do design learning at Intel, so I know who's registered. And I could get data from D&B to help me understand, is there enough R&D budget? I might not know exactly what it's allocated to, but I could get something. So through a series of understanding what it took to do a design win, we created this model. And we said, dear sales teams, now you should completely reorganize and organize in what are the most likely accounts to buy from Intel and design on Intel. So what did the sales team say? Are you crazy? I get paid on commission. I'm not reorganizing based on what some model says that you should reorganize. And we said, well, why don't we give it a try, right? So we picked one region, one call center, and we said, organize these people for 90 days, 1 quarter, by what the model says, not how they're currently done it. And within 1 quarter, right, those sales resources were 5 times more productive than their peers. They all exceeded their quota for the quarter, right? And over the last year and a half, they've generated $187 million in incremental sales to Intel. And I tell that story because it's more than a technology story, right? It's a business transformation story. And so when you come with great insight that analytics can provide you, it means the management system has to change to support the new insights. And that's what we found has been instrumental for us at Intel to help us grow the business. So we took this one step further, and that was a sales example. We went to a marketing example. How many times do we run marketing campaigns where you come back and you say, how effective was that marketing campaign? And sometimes people have a number of qualified leads, and sometimes they'll know what those leads converted into something. But really it becomes very fuzzy how effective a marketing campaign is, particularly if it's a branding-oriented campaign and not a demand generation campaign. So we went to marketing and we said much the same thing. We think we can help you. Using some machine learning that would help us personalize our offers to people that then would generate revenue. So it's an interesting thing for us to say that because we don't actually sell anything to end users. So how would that work? Because we're an ingredient in someone else's product and not a direct end user sales, right? So what we were able to do was work with them to help get very clear alignment on our data, right, and the foundation of the data. So we had to simplify our what we call master data or model data for these complex queries, and then allow users, internal users, not our customers, to use those complex queries. And what it was able to do is help them understand the performance of their campaigns better. What used to take them maybe months or days of after the fact data collection to say, did that campaign that we ran with HP or Dell or whomever work, they were able to collect that data through a series of social feeds that we used within 24 hours and talk about the efficacy of that campaign. And then we could either kill the campaign, expand the campaign, or whatnot. And through that change, we were able to save $170,000 a quarter in marketing dollars that then can be redeployed into other demand generation activities. So really starting to build out and solidify our complete digital marketing experience for a company that doesn't sell anything to end users. That's the more interesting part of that. So we're closer to our customers than we've ever been because we're able to use the analytic data streams in a productive model way. So that's not the only problem we have at Intel, is to grow the business, but we have to also, we're in a time period where the life cycle of our products is shrinking. So therefore we have to get more products to market quicker each and every year. And that becomes a real challenge for us. So it takes us, a couple years in design, a couple years to design manufacturing locations. And so every quarter counts in terms of our ability to shrink that time to market. So a couple things we've done in manufacturing. So we have historically run on any given wafer, there are billions of transistors. And then the wafer gets cut up into different products. So there'll be thousands of products on any given wafer. And what we have to do is test every one of those transistors, that when the circuit is closed, that no electricity flows through there, and if the circuit is open, it flows. And that sounds like a simple test, but when you have to do it billions of times, it takes an enormously long period of time to do that. And so what we've always used is statistically valid random sampling testing for the wafer. And then at the end of the line, we package them, we cut them up, and then we test them again, and then some of those products fail, and we throw them away. So it costs us a lot of money if something gets to the end of the line and we have to throw it away. So our current generation of products that are out there are called Skylake products, and one of the things that we did was we started to move to precision and personalized testing. So we create samples of every product before we ever go into high volume production, and then from those samples we go and we make engineering changes. So we have the test data for the samples, we have all the logs for the engineering data, and we look specifically at what's been tested before and then what engineering changes were made, and specifically on that wafer, what would have changed. And then we test only those circuits that had been changed using this machine learning model, feeding all the data in before. So with the Skylake generation of products, what we were able to do was do a lot of work on that model around voltage there. To when we use more voltage, we actually drain the battery and we drain the life of the product. And so by doing that, we were able to guide the engineering changes to areas that would help reduce the voltage compensation. And what happened when we released the product after those kinds of testing with no incremental cost, right, we are able to improve the battery life by 2% and the video playback period by 2%. Doesn't sound like a lot, but every percentage counts in how well that product will perform in the marketplace. So then Cherry Trail, which came after that, we said, you know, we were in the process and we thought we could take this same model and that same machine learning algorithms and apply it to other products. So in this particular product, it had a completely different problem. It had a problem that on the sample parts, when you closed the laptop, it didn't always go into hibernate. When it's supposed to go into hibernate, it went into sleep. And so we had this problem, it wasn't performing the way it should. So we took the very same algorithm, we adjusted it for the different data points that we needed to test, what would drive it to go into hibernate or sleep. And within 8 days, we were able to deploy that machine learning model, run some sample parts, and automatically drive the engineering changes that needed to be made to fix that quality problem. And the reason I give that example is because in the past, these would have been 2 independent problems solved by 2 independent teams, and they would have taken months and months and months of analysis and engineering changes and tests to figure out what was going on in order to improve the quality of that product. And so what we're finding as we build our library of algorithms specific to our business model, that there's a tremendous amount of reuse. You may end up changing just the data ingestion elements that you want to analyze, and that's a very small change relative to having to start and build algorithms from the beginning. So we took that one step further also, and we looked in manufacturing, and then we did analysis on things that took a long time for the manufacturing team to address. And so again, we have about a terabyte of data on every wafer when it is going through the manufacturing process. And you had people using Excel spreadsheets to do the analysis to figure out, you know, is that wafer going to be good when it's done? Will it have the performance specifications that we expected, et cetera. And what we did was implement a what-if model with all that data that allows our factory engineers to run those scenarios real time. And what was taking them 4 hours is now down to 30 seconds. Automated, it's effectively automated. They still have to do some work at the end, but 30 seconds from 4 hours. And that ultimately, because it will allow us to kill products that are going to be bad at the end of the line much earlier, we believe that will save us over $100 million by the end of next year. So, and all of that is collecting a lot of the sensor data that exists already in manufacturing. So those are some of our examples and what we're working on and how we're trying to use data to change both the growth of our business as well as the operational performance of our business. But it's happening in government too. I also sit on the Commerce Department's Data Advisory Council. And the Commerce Department has, I think, been a leader in figuring out, you know, new ways to use data, making data easier to find for those who need to use it, whether they're private citizens, other government agencies, businesses, whatever. And they've launched the Commerce Data Usability Project. So we all know sort of data.gov has been a great, what I call Generation 1 product, although it doesn't have the usability that I think for the masses to adopt it. And so out there now, and it's launching by the end of this month, the whole project, but out there right now are tutorials about how to use data from census, from NOAA, from NIST, et cetera. And I just think this is a great example of where government is actually moving quickly forward with new data models that will enhance businesses, private citizens, and other parts of the government. So, I always say this Commerce Department is getting started. I'd like everybody to get started. So there was one thing that's pretty certain, that the advancements in data science are available to everyone, and you'll never have all the data scientists that you need, and you'll probably never have all the money you need, but you can start your journey now. And by the way, you'll never have all the money you need. That's true if it's government and or business. We never have all the money we need. But you know, when we really think about it, so I always think about big data analytics as a way to execute our strategy. What are we trying to get done for the business, and how could we do that better with data? And then we start small. We like to say we start with 5 people over a 6-month period of time, and we drive to $10 million worth of value. And because we're Intel, we go 5 plus 6 equals 10, and we think that's really funny. Because we've proven that these small teams can actually drive a lot of value. So then I talked about the need for management system changes, and you know, you have to shift the dialogue from what happened, like why did this go wrong or why did this work, to what will happen, right? Why will it happen, right? And overall improve the analytics IQ of all of our constituent base. So these are hard concepts for those who aren't technical, and I think it's incumbent upon us as the technical community to help change the management system and the business processes that then will support improvement in our overall organization. So with that, I thank you, and move on to the next question.